All right. A store owner ordered 25 calculators. That cost $30 each. The store owner can sell each calculator for $35. And then the store owner sold 22 calculators. He had to return 3 and pay a $2 charge for each returned calculator. Find the store owner's profit. Okay, so first of all, you have to understand what profit is. And so if you don't understand that, that's going to be very difficult to solve the problem. That profit equals revenue minus costs. And so revenue is the amount of money that the store owner brings in, and then, of course, cost is what he paid for all of his merchandise. So, so there's really two things that we need to work out. So if anything, you know, if you want to make like two columns, you know, you're figuring out your revenue, you're figuring out your cost. So if we do revenue, what do we have to work out to figure out that revenue?
I calculated what the calculators were if you would have sold them at that price. I did both of them, what you could sell and what you bought them for.
Okay, so explain a little more detail.
I would do, because I have some reference here, 25 calculators times 30, and I got that cost.
Okay, so cost of 25 calculators times 30.
And that's what he could have had, or, yeah, that's what.
Well, that's what he paid for them. Yeah, that's what he paid.
He did $35, he sold them at times the amount of calculators he sold, so 35 times 22.
Okay, so 35 times 22 for what he brought in. How much does that add up to? Okay, $770.
And then calculate $3 times the $2 that he's going to have to pay back.
Okay, so three calculators at $2 each. Okay. Okay, so this is a cost also, so I've written it over here. Okay, anything else?
Now you would subtract the $6 from the revenue.
Okay, so you can. There's one thing that you're missing, though.
The price of the 3 calculators.
Right, because why do you return calculators? To get credit back. There's no other reason you would return them. If they're broken and you can't get your money back, you're just going to throw them out, right? And so you're not going to pay for somebody to take back calculators if they're not going to give you something in return. So the whole purpose of the return is that you're getting that credit back. And so that would be more revenue. That's money coming back into his pocket. So we have 3 calculators at how much each is he getting back? 30. Okay, so keep in mind that there's more than one way to do this problem. Some of you guys might have, subtracted the $2 from the 30 and then figured out that, that's what he's getting back. And, again, there's more than one way to work a problem. But now we have all of the money factored in. So altogether, he's got, okay, so add 90 here. Okay, 860 is in his pocket, but we have to take away the cost of 756, and gives you a profit of 104. Okay, so bringing up the point of more than one way to do a problem. Most math problems have like 3 ways to do a problem, if not more. So just because I demonstrated one way in class doesn't mean that you don't have another way that you can work it out that works out okay as well. You know, some people like to figure out, okay, how much profit am I getting on each calculator, you know, just first. And you say, okay, 35 minus what I paid for it, 30 is $5. So I get $5 profit for those 22 calculators. And, you know, and then figure it out that way, minus the, and then you'd have to subtract the charge that you have to spend back, you know, to send back those calculators. That would also get you $104. So again, just because it's done one way in the book or one way in class doesn't mean that that's the only way to do it. And another reason why I'm asking you to show work when you're doing your test, because, you know, everybody has a different way of doing things. So that way we can, you know, work through it if you have questions. So any other questions on something like this? Okay, so chapter 2 starts our chapter on set theory. And there, typically at the beginning of a chapter there's vocabulary, so you can sort of get used to that routine here in this textbook. But a set is a collection of objects called elements or members. The NFL is a set of football teams, so just an everyday type set so that you're familiarized with that. Each team is an element or a member of the NFL. Okay, so there's 32 teams in the NFL, so there's 32 elements in that set. And then just a reminder, you have fill in the blanks on your handouts as you're going, and then occasionally, like these examples, I don't believe are on the handout themselves. So if that's something that you'd like to add to your handout, you know, make sure to write that down. A set is well defined if its contents can be clearly determined. For example, the set of students in this class is well defined, since we can name everyone in here. I have a roster of exactly which students belong to this class. Now, the set of the 3 best cars is not well defined, since best can be interpreted differently. So anything that's subjective, it's based on someone's opinion, is not well defined. There are 3 methods that are commonly used to indicate a set: description, roster form, and set builder notation. Okay, description, roster form, and set builder notation. We're going to look at each one of these individually. So for description, that means that you're going to be using a word or a couple words to describe what's in the set. So can somebody raise their hand and describe the set containing the elements winter, spring, summer, and fall? Who wants to take a stab? Seasons, right. So that would be a great description for that set, the seasons. The first example that I used was also a descriptive way to say the set. The NFL, that was a descriptive way to describe, you know, what we were talking about there, the National Football League. Okay, if you're putting something in roster form, then you are listing the elements of a set inside of a pair of braces. I want to make sure that everybody is clear on what all the symbols look like. So these curly type grouping symbols are braces, as opposed to brackets, which are the square ones, and parentheses, which are the curved ones. Okay, so it's really important to know the difference between your grouping symbols, because in set theory, we use braces. So make sure that that's clear when you're writing out sets and so on. So the set containing red, blue, and green. Note that in roster form, order is not important. So it doesn't matter, you know, what order you write your set in. But if we were going to write this in roster form, we want to start out with a curly brace, and then we would list our colors in there with commas between them, red, comma, blue, comma, green. But if you wrote blue, comma, red, comma, green, same set. Okay, so as far as order, it does not matter. Now, if you're working in Math Excel, it might specifically, you know, say you're writing numbers in a set, it might specifically say write your numbers in ascending order. So you need to pay attention to any specific instructions Math Excel gives you before you type it in. If it doesn't specify, then order shouldn't matter. It should take whatever order you type in. All right, so I have several examples that are not on your handout. Oh, sorry. We have to go through one more vocabulary, I think, on there. So sets are generally named with a capital letter. The natural numbers is listed like this, so with a capital N. And so notice we're using a capital for natural numbers, and then we put equals and the curly brace. So the natural numbers are also called the counting numbers because they start with 1, 2, 3, 4, and so on. And then the integers, we're going to use a capital I. And so you'd say I equals the set of ... -3, -2, -1, 0, 1, 2, 3, ... Okay, does anybody, you know, I guess you could probably look at your handout, but the ... what is that signifying?
Keeps going on.
Okay, keeps going on forever, right. So you're following that pattern. So it's called an ellipsis. I'm not going to test you on that word. It was just so that in case that word pops up somewhere, you understand what they're talking about. So the natural numbers go on forever in the positive direction. The integers go on forever in the positive and the negative direction. Okay, so this is the part that's not on your handout. So somewhere in your notes or you know, off to the side, if you printed your own handout, you can put it on the back of the handout or something. But we want to express the following in roster form. So the first example is set A is the set of natural numbers less than 5. So this is why we had to go over the vocabulary of natural numbers and integers, because the questions are going to ask you to specify certain numbers. So you need to make sure you're familiar with those sets of numbers. Okay, so first of all, what's the name of this set? Set A. So you got to start with the letter A, and then we're going to put in equal sign, and then open up your curly brace. So hopefully you wrote A equals the set of 1, 2, 3, 4. Now, some of you might have written 4, 3, 2, 1, which is a common thing because it said less than 5, and so a lot of people like to start with that highest number, and that's fine because order doesn't matter unless you are specified a particular order in the question. And then remember, natural numbers start at 1, so this set does not go on forever. Okay, next, set B is the set of integers between 13 and 25. All right, so does anybody want to raise their hand and tell me what we should write for this particular set? Tabitha?
B equals, brace, ... start with 13, goes through 25.
Okay, so the next number would be?
14.
Okay. Okay, I've run out of space.
And then close brace.
Okay. So the ... would imply that this goes on forever down, okay? But it was just between. Okay, so it's not actually going to go less than 13, okay, because it's just between. And there's actually one more thing with the word between. Okay, there shouldn't be 13 and 25 either. Okay, so this is a common confusion here. Because it's between, you only want what is between those boundaries, not the boundaries themselves. So we're not going to include 13 or 25. and no dot, dot, dot at the beginning. Okay, so here's what would be on that set. Now, there is one way you could write the set with the ellipsis. Okay, I heard 14 dot, dot, dot 25. However, well, yes, 24. Okay, but that's not where I was getting at. But yes, good point. It's got to be 24 at the end. If you're going to use an ellipsis, you have to be able to show the pattern of what's happening in the set. So if you start with 14 and you say dot, dot, dot 24, that doesn't necessarily show that there's integers in there. You could have 14, 14.1, 14.2, 14.3, 14, you know. So you have to be able to show a pattern. So you need to have at least 3 numbers in the beginning to show your pattern. And then you can do the ellipsis and your last number. Now the way that I did it in here, I put more than what I needed to, and it's always okay to put more than what you need to. But I put 4 numbers, the ellipsis, and then 2 numbers at the end. But these numbers were not necessary. I could have dropped those numbers and it'd still represent a solid pattern, and knowing that it's going to end at 24. Okay, so any other questions on this particular roster form? Okay, set P is the set of primary colors. So from time to time, the homework will throw stuff at you that's not necessarily content from this course, but it's sort of like everyday knowledge type stuff, you maybe you've learned growing up, or maybe it's you know, something current event type stuff that's a common knowledge type thing. Now, if that's not something that you know, you can Google it. Good. Okay, so notice that you always have Google to help you. Now, you wouldn't have Google on a test, so I try to make sure that there's not these obscure questions on a test that is stuff that maybe we've talked about in class. Now, so raise your hand if you know what the primary colors are. Yes, ma'am. Red, blue, and yellow. So if you wrote your set, I put red, yellow, and blue. Is that the same thing? Yes, good. Okay, because order doesn't matter. So very good. But so now primary colors is fair game because I've talked about it in class. Okay, and it's in your notes. But otherwise, you know, if it's an obscure thing, I try to make sure it's not on the test. But it could very well be on the homework. And it just means you need to just do a little bit of research to figure out what those items are. And then our last example here, set D is the set of integers between -2 and 1 inclusive. So D equals the curly brace, -2, -1, 0, and 1, close your brace. Good. So what was different about this problem? Yes, question? Or we used -2 and 1. Yeah, so what was different about how the question was worded? Inclusive. Okay, so you need to make sure you're paying attention to those key words. So inclusive means we're including those boundary numbers. If you don't see a word like that, like in the second example of set B, then you're not going to include what it's between. So it could be, you know, -2 and 1, including the boundaries, inclusive, you know, whatever it might be, that same type of word. Okay, so now we're going to move on to set builder notation. So back to what's on your handout. Set builder notation, if you're writing it in that format, then it always looks very similar to what's written here. You start out with the name of the set, just like you did in roster form. And so if you were to read these symbols, this is how it reads. On your handout, you already have these bubbles here, or these pop-ups. So set S is the set of all elements X. Now this letter could change. It could be all elements Y. Whatever variable works for the problem that you're writing out. And then that vertical bar means such that. So if you took intermediate algebra or possibly college algebra, there were some homework questions that asked you to write your stuff in set builder notation. And so that's what this was. It was you had to identify the variable of the equation and then put your conditions. So this is how you will always start set builder, with the exception of the letters might change depending on the name of the set or the variable that you're using. So set F is the set of all elements X such that, and then you have to list the conditions that all of the elements need to meet. And that could change. Now, when we're writing these conditions, lots of times we're going to use less than or greater than symbols, or we might use, we might have to identify what type of number it is, like an integer, natural number, and so on. So here's an example. Set A equals the set of all elements X such that X is greater than or equal to 16 and X is an integer. Okay, so I've listed the set of conditions that any element must meet in order to be part of this set. Now, another way we can write this is like this, okay? The only thing that's different is instead of putting X as an integer, we use some new symbols here. We have X and that curvy E and the abbreviation for integers, which was the capital I. So that curvy E means an element of. If you want to note that it's not an element of, you use the same symbol with a slash through it. So you have those symbols already written at the bottom of your handout. So when you are writing your items in set builder notation, you always want to write them in the shortest possible way that you can. Notice that instead of using the words less than or equal to, we use the inequality symbol. And instead of using the words is an integer, we said element symbol capital I. Now notice that you always need to have the word and in between your conditions. So you can't just say X is greater than or equal to 16 element of I. You need to have and X is this, X is this, X is this, and X is this. So you're repeating that variable that you're using, putting a word and between each condition. Now, we could have also written this in roster notation. It would be set A is the set of, what's the lowest number in this list? 16, because it's greater than or equal to 16. So 16, 17, 18, and then ellipsis, dot, 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 because I've showed 3 numbers to show my pattern. So just making sure that you pay attention to what method it wants you to write your answer in. Sometimes it'll give you the set in set builder notation, and it'll say, okay, rewrite the set builder into roster notation. Or you might start with the roster notation. It'll say, okay, now rewrite it into set builder notation. So you're going to have to be able to, translate one method to another. Here's another set builder notation set. So the set F is the set of all elements X such that X, so now that curvy E means what? Is an element of, and capital N stands for natural numbers. So X is an element of the natural numbers, and X is less than 3. So go ahead and rewrite this set into roster form. Okay, so hopefully you wrote capital F equals the set of 1, 2, because those are the only natural numbers that are less than 3. Now, obviously, for this particular set, roster form is a lot easier, a lot less to have to write, and so on. So sometimes roster form is easier, but sometimes there are sets that cannot be written in roster form because there's not a pattern that you can write in there, or the numbers go on for forever with no pattern. So step builder notation is sometimes the only way you can write the set in that format. So see if you can write this set in set builder notation. Okay, so this is not on your handout again, just another example. So the set S contains all elements that are greater than 5 and not an integer. Okay, so just to repeat that first one, because we may have had audio issues there. So set A had 5 distinct elements, okay? So 6, 15, 2, 0, 9, 19. We did not count the second 15 because it was not different than the first one we already counted. So cardinal number of A is 5. So looking at B, so the cardinal number of B is 1. Okay, so even though it's this is what throws people off sometimes too. It's a 3-digit number, so sometimes I get an answer of 3, but there's just one number in there. So your cardinal number is 1. Okay, so for C, 8, does everybody agree? Okay, 8. So even though we only see 5 numbers, the ... says that there's a pattern going on in there. So we have to count the missing 12, 13, and 14 as well. And then the last one, the cardinal number. Okay, I was going to actually give you credit, but it's not empty set. Remember, when you're doing cardinal number, you're trying to figure out what's the amount of elements in the set. 0. Right. This is the empty set. Okay, D is the empty set. But when you're trying to figure out the cardinal number, there's an amount. What's the amount of elements in the set? Well, there are 0 elements in the empty set. Okay, so again, common source of confusion on that. So just make sure you realize that the cardinal number, there's always an answer that's numeric, because you're trying to figure out an amount of items in there. Okay, so there are all our answers there at the bottom that we found. All right, set A is equivalent to set B if and only if the cardinal number of A is equal to the cardinal number of B. In other words, 2 sets are equivalent if they have the same amount of elements in them. So they don't have to be equal. They don't have to have these same exact elements. They just need to have the same amount of elements. So taking a look at these 2 sets, set A is equal to the set of Frasier and The Tonight Show. Set B is equal to the set of Kelsey Grammer and Jay Leno. So are these 2 sets equivalent? Yes is correct. Good. Because you just have to count how many elements are in each. So looking at set A, what is the cardinal number of A? 2. There are 2 TV shows listed in there. And then set B, 2, okay, because there are 2 people listed in there. So since they each have 2 elements in them, they are equivalent. Now, are they equal? No. Okay, they are not the same exact elements, so they are not equal sets. Okay, equivalent sets can be placed in one-to-one correspondence. In other words, we can match up items and we won't have any leftover items because they have the same amount of items. So in that last example, you know, we could match up the person that belongs to the correct show. So Frasier matches to Kelsey Grammer, The Tonight Show matches to Jay Leno. There would be an equal amount of items to match up to each other. Another example would be the set of student names and the set of student IDs. There is an equal amount of student names on the roster than there is a list of student IDs on my roster. So I could match them up. And it doesn't even matter if I match them up to the correct person. The point is that I can match up each ID to a person and not have any leftovers. So that's what it means to be in one-to-one correspondence. A finite set is a set with a defined number of elements. The set of students in this class is a finite set. So there are 18 students on the roster. I know exactly how many students are in this class. Set A is equal to the set 1, 2, 3, 4, 5. This is a finite set. It has, another way to put it is that it has an ending. Okay, there are 5 elements in here. It does not go on any further than that. You can count how many are in there. So the opposite of a finite set would be an infinite set. A set with an infinite number of elements. So the set of natural numbers is an infinite set. When you start counting up the numbers, 1, 2, 3, 4, 5, and so on, it goes on forever. So you cannot define the amount of elements that are in there. This set that we did earlier, this was the example of what you had to write in set builder notation. The set of all elements x such that x is greater than 5 and x is not an integer. This is an infinite set. And now if you think about it, this is the set that cannot be put into roster form. What would be the lowest number in this set? Well, 6 is an integer, so 6 is actually not in this set. Well, 0 is less than 5, so it's not in the set. And 0 is also an integer. So let's name one number in this set. Let's not worry about the smallest number. Let's name one number in the set. Well, 5 is not in there because it's an integer and it has to be greater than 5. Think about what's not an integer. That's still an integer. What kinds of numbers are not integers? No, negatives are still integers. Decimals, okay, that's one number that's not an integer. Yeah, you guys are way overthinking this. Okay, a decimal number, that doesn't that doesn't end in a .0. Okay, that's not an integer. So 5.1 could be in this set. What other types of numbers? Something else you could write that's not a decimal, but you could rewrite it as a fraction. Okay, so 13.5 could be one of the numbers in this list. So when I ask you again, what's the smallest number in this list? It's actually impossible to tell because you could put 5.0000000000001, and that still wouldn't be the smallest one because we could add a few more zeros in the middle there as long as we end it with a 1. All right, so this is why some sets cannot be listed in roster form, because you just can't list the numbers individually and completely. So that's why set builder notation is very important, because it's at least a way that we can write something as a set with a shorter description of it. So this is an infinite set because we can always continually name fractions and decimals that are bigger than 5 and that are not integers, and it can go on forever. Okay? All right, so it's sort of a little bit of a trick question. Okay, this is our start of 2.2. I'm going to just hold off for a second so we can look at some more examples from Math Excel. Okay, so section 2.1, and just to give you an idea of what some of the homework questions are going to look like. It says, determine if the collection is not well defined and therefore is not a set. So the collection of U.S. airports. So you're coming up with whether it's not well defined or well defined. Now, when we do examples in class from Math Excel, so you get used to what I like to do in class, if it's a multiple choice question, I like to give everybody an opportunity to answer without calling out anybody or, and also everybody having a chance to quickly answer. So what I do is I number the choices. So the first choice would be number 1, and you could, show your index finger, okay, I choose number 1. The second choice would be number 2, so show me 2 fingers on your hand, and just show you, right here in front of you so that I can clearly see it, but not giving away the answer to everybody else. Okay, so choice 1 is not well defined, and choice 2 is well defined. So if everybody answers, quickly, then I can sort of have an idea if everybody's on the same page. Okay, so choice 1, not well defined, or choice 2, well defined, and it was the collection of U.S. airports. Yep, so show me your choice, 1 or 2, 1 finger or 2 fingers. And then I always go with the majority, so I see a majority of 2. Okay, so second choice. Excellent. All right, because can we list all of the U.S. airports? And nobody's going to doubt you whether it's a U.S. airport or not? Nobody's going to question your, your definition of what a U.S. airport is? Right, so if you can list them and there is a clear definition of what those items are, then it is well defined. Now, if somebody were to argue with you, no, that's not really a U.S. airport, then it would not be defined, okay? So again, quick answers like that, that allows me to see, okay, some people aren't quite there yet with the concept, so I can give a better explanation of the problem. All right, and then sometimes your questions are going to be, write a description of the set. And so here we have multiple choice again. And so you have the set of 15, 16, 17, 18, dot, dot, dot. And so you have 4 choices of a description of this set. Choice 1, all rational numbers greater than 14. Choice 2, all natural numbers greater than 14. Choice 3, all natural numbers greater than 15. Choice 4, the numbers 15, 16, 17, and 18. Okay, so there was a new word that popped up in there that wasn't on your handout, but it is something from prerequisite material. Okay, so choices 1, 2, 3, or 4. If you're not sure, just take your best guess. And I see a majority of 2. Excellent again. Okay, so first of all, you saw the word rational numbers. So rational numbers, just to remind you from, an algebra class, rational numbers are any numbers that can be written in the form of a fraction. So natural numbers actually are rational numbers because the number 15 you could write as 15 over 1. But not every rational number is a natural number, as we just discussed. 13 and a half or 5/7 is not a natural number. And then we wanted, so then knowing that these were natural numbers, we needed to see greater than 14 or greater than 15. Well, since 15 is included, we want greater than 14. Now, had there not been a dot, dot, dot in there, had there not been an ellipsis, then the fourth choice would have been our answer. Okay, but the dot, dot, dot says that's going to go on forever, greater numbers than 14. Okay, so now you're given a set in set builder notation, and you need to rewrite it into roster form. Okay, choice 1, the set of 3, 4, 5, comma, dot, dot, dot. Choice 2, the set of 3, 4, 5, comma, dot, 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 comma, 100. Choice 3, the set of 4, 5, 6, or choice 4, the set of 4, 5, 6, comma, dot, dot, dot. Okay, so 1, 2, 3, or 4. Okay, so I see a majority of 4. Fantastic. Can you guys figure out what my favorite compliment is in there? So, fantastic. All right, so good choice, because notice the first one included a 3, but it did not say greater than or equal to 3. Had there been an equal to part in there, then we would have included the 3. And then the second one, well, it stops at 100, but it doesn't say it's going to stop at 100. It says greater than 3, so keep going on forever. And then, of course, the third one doesn't have the ellipsis saying that we need to go on forever. All right, let me show you a different one that we haven't looked at yet. So notice this one has a compound inequality in there. So the set of all elements x such that x is a natural number and 10 is less than x is less than 60. I'll let you think about that for a moment, but I'll give you another way that you can say that a compound inequality. Okay, you've got choice 1 is the empty set. Choice 2 is the set of 11, 12, 13, 14, all the way up to 59. Choice 3 is ... 8, 9, 10, 60, 61, 62, ... And then choice 4 is the set of 10, 11, 12, 13, ... to 60. Okay, so take a stab if you haven't already. I see a majority of choice 2. Nice work. Okay, so another way that you can say this compound inequality, and what's important is that if you have to go from words to set builder notation, I want you to know the way you can actually say this out loud. You could say it the way I said it. I strictly translated the symbols. 10 is less than x is less than 60. But another way to say that in words is x is between 10 and 60. So notice we had an example of that in roster form in our notes. X, or the element, or the number is between 10 and 60. So if you have to rewrite words to set builder and you see the words between, that means you're doing a compound inequality like this. So notice that there were no equal signs on the symbols. So therefore, we started with 11, because that was 1 higher than 10, and we ended with 59. Okay, so that's the difference between B and D. And then C was saying everything outside of 10 and 60. No, so we want anything between 10 and 60. Okay, so the other types of things you're going to be doing is identifying whether certain sets are the empty set or not empty. So the set here is the set of all elements x such that x is the number of living Russian czars born before 1700. So x is the number of living Russian czars born before 1700. Make sure you read it carefully. Okay, choice 1 is the set is empty, and choice 2, the set is not the empty set. Okay, 1 or 2. Let me see your choices just right in front of you. That's okay. I think I see a majority of 1. And you would not be correct. Okay, because it's the way it worded it, the way the set was worded. It's the number of living Russian czars. How many living Russian czars are there before 1700? Born before 1700 that are still living? None. Okay, but it wanted the number of those, 0. Okay, so the number So we could also rewrite this set as the set of the number 0. Okay, because it wanted the number of living Russian Tsars born before 1700. There are 0, so that means the set is equal to 0. Now, if it wanted to list the names, okay, X is the name, or names, okay, I guess that would be singular. X is the name of a living Russian Tsar, or X is, you could even cut out this word, X is a living Russian Tsar born before 1700. Well, there are none that you can list in the set. Okay, so that's the difference between an empty set and one that has a number in it. All right, so they want to be very tricky with you guys to make sure that you really understand the concepts. So any other questions there? Okay, now notice that this only had 2 multiple choices, so I did not choose the right answer, so I was marked wrong off the bat. If there are 4 choices, I think it might give you one more shot to answer it correctly. It all depends on the question. So you would have to click similar exercise if you want another shot to get this right. Okay, X is the number of women who served as U.S. President before 1900. Choice 1 is not the empty set. Choice 2 is the empty set. Okay, I got a majority of 1. Fantastic. Okay, so you're learning because it used the words the number of. Okay, the number of women, well, there were 0 women who have served as president ever. Okay, so there are 0 women, there is a number in that set. Okay, if it didn't have the words the number of, then it would be empty. Okay, and then the other thing that it wants you to get used to is these symbol notations. So it says 1, and then what does this symbol after the 1 mean? Not an element of. So 1 is not an element of the set 1, 2, 3, ... 29. So is this true or false? So choice 1 or choice 2? Okay, I have a majority of 2. Because excellent, that is false. So 1 is inside of that set. There is a 1 listed in there. And so therefore, instead of using the element symbol with the slash through it, it should have been just the element. Take away the slash. Okay, 15 is an element of the set of all elements X such that X is a natural number and X is between 18 and 28. Notice that we're including 18 this time, okay, because there's an equal sign there. All right, so choice 1 is true, choice 2 is false. All right, looking at show of fingers, I've got majority of false. Good job. As 15 is an element of this set. Now, sometimes to answer this question, it might help to rewrite it in roster form so that you could see it better that way. Sorry. So, what is the lowest number in this set? 18, because it's equal to 18, and it's between 18 to 28. So we need 18, 19, 20, ... we're going to go up to 27, 28, and so on. So it's saying that 15 is an element of this set. So is 15 amongst this list of numbers? No. So that's why this was false. The way that I could have fixed it is I could put a slash through there, and then that would be a true statement. But if you need to rewrite it in roster form to help you answer the question, go ahead and do that, however you need to visualize that. And then the only other type I want to show you are whether sets are equivalent or equal. Okay, so set A is equal to the set of 1, 1, 1, 3, 3, 5, 5, 5. Set B is equal to the set of 5, 3, 1. So the first question is, are these equivalent? Okay, but then not only do you have to determine whether they're equivalent, you have to answer why. So you have 4 choices here. The sets are not equivalent because A does not contain the exact same elements as B. Choice 2, the set are equivalent because A does not contain the exact same elements as B. 3 is they are equivalent because the cardinal number of A is equal to the cardinal number of B. And then 4 is they're not equivalent because the cardinal number of A equals B. Okay, so I had a majority of 3 that I'm seeing. Very good. Good job. Okay, so make sure that you're reading these carefully. Are they equal? It's either equal or not equal. Are they equal? Equal means they have the... Okay, they actually have the same cardinal number because remember that you don't count the repeats. So there's 3 up here and 3 here. And not only that, though, they have the same exact numbers in there. They have a 1, they have a 3, and they have a 5. Even though there's multiple 1s in the first set, they're still showing the same exact elements in there. They have a 1, they have a 3, and they have a 5. The amount of those does not matter. So therefore, they are equal because they contain the exact same elements. Okay? All right, so homework is to do section 2.1. And then don't forget to get your personal information assignment done and enroll in the Math Excel course if you haven't done so already.